Hello, welcome today to a very interesting class. We have a problem here. A cube of size 0.1 meters hangs freely from a string. What is the upthrust on the cube when totally immersed in water? We are given the density of water to be 1000 kilograms per meters cube, and acceleration due to gravity is 10 meters per second square. Now, what are we going to do here? There's a very popular and famous principle propounded by Archimedes. What does it say? It says that when a body is wholly or partially immersed in a fluid, such a body experiences an upthrust, which is equals to the weight of the fluid displaced. Let me put it again. When a body is wholly or partially immersed in a fluid, it experiences an upthrust, which is equal to the weight of the fluid displaced. So what that means is that if you push any object into a fluid, let's just call it a fluid, it can be water, it can be gas, and it can be air. When you push any object into a fluid, the volume of that object that goes into the fluid equals the volume of that fluid that will be displaced. Before the object will go in, the fluid has to make way. So that same volume of the object that is going in equals the volume of the fluid that will be displaced. That is what we are going to use, to get our answer as required by the examination body. Okay, so here we are. We know we've been given a cube. With a cube, what's the formula for volume of a cube? So we have it here by way of our solution. Okay, volume of that cube is equal to what? 0.1. We've been given the side as 0.1 multiplied by 0.1 multiplied by 0.1. Okay, what would that give us? That should be 0.001 meters cube. That's the volume of the cube. We are told here that totally immersed means the entire cube goes into the fluid, and in this case the fluid is water. Okay, so the volume of water that will be displaced as the entire cube goes in equals the volume of the cube itself. Okay, so we've been given the density of water. Remember, density equals mass over volume. Have you seen that? Density equals mass over volume. So mass, if we need to know the mass, that will be what? Density multiplied by the volume. So in this case, what's the mass of water displaced as the cube goes into it? So that's going to be the density of water here, which is 1000, multiplied by the volume of the cube, which is going to be the same thing as the volume of water displaced. Okay, so when we deal with this, we end up having 1 kilogram. Have you noticed that? What we have is 1 kilogram. Okay, so that means the mass of water displaced as the entire cube goes in is 1 kilogram. Now, how do we convert mass, to force? Okay, remember, we've been given acceleration due to gravity here. So what that simply means is that our upthrust, okay, some will call it buoyant force. Our upthrust in this case will be equals to the mass of water displaced multiplied by what? Acceleration due to gravity, which is what? 10 newtons. Okay, that's what we have. That is just it. So in case you've not clicked the follow button yet, do so. Thank you.